Okay, summer school. I am trying to help you out with stoichiometry, the section that has limiting reactants in it. And so we're going to kind of go through all the steps. So it's going to take a couple of videos to do this, but eventually I'm going to work some limiting reactant problems with you to try to help you out. So the very first thing that you need in any stoichiometry problem, which stoichiometry problems are essentially going from one thing to another, is a balanced equation. We always want a balanced equation. So make sure every equation that's ever given to you is balanced. If it's not balanced, balance it for yourself real fast. It's going to save you a lot of time and headache and help you get the right answer. So we need a balanced equation. It's right here. I have a balanced equation. We will be using it shortly. Now then, if you recall about moles, moles is saying our ratios. That means for every 2 of these, I need 1 of these. If I have 2 of these and I have 1 of these, I can make 1 of these and 2 of these. That's all it's saying. So it's just telling you your recipe. So it's kind of like baking, essentially. But most of the time in baking, you have one product. And in this case, we could have multiple products. But all that to be said, it's just proportions. And those numbers in front are telling you how many you have. It could be one single particle. If I have one molecule, if I have 2 molecules of copper chloride, copper 1 chloride, and I have 1 molecule of sulfuric acid, and I combine those together, one teeny tiny molecule, it's going to make 1 molecule of copper 1 sulfide and 2 molecules of hydrochloric acid, individual molecules. Do it on a larger scale, you're going to get more. It's just cookies is the best way to explain it, because if I mix a small amount of stuff, I could get enough dough to make 1 cookie, or I can combine and make more ingredients to make more cookies, which is what we normally do, because most sane people don't just eat 1 cookie. So we're going to go ahead and work through some things, but a couple things we need to remember. To be able to be successful in stoichiometry, you must know how to calculate molar mass. It's going to happen, because we're going to have to convert from grams to moles and moles to grams. And so the first thing that we're going to go over is how to convert from grams to moles and moles to grams. So if I have the molar mass of, and we're going to use water, so water, H2O, molar mass, roughly rounded, is 18 grams per mole. That's the molar mass. Now then, if I was told that I have 0.5 moles, and I want to know how many grams that is, first thing I need to do is always start with my given. So I'm going to put my moles over 1. And then I'm going to take my molar mass. This is 18 grams per mole. Another way to say that is for every 18 grams I have, that's going to be exactly 1 mole. So here's this proportion right here. So we want moles to go on bottom to cancel, so that means grams are going to go on top. So then I'm going to multiply it, and again, moles are going to go on bottom to cancel, and grams are going to go on top. So it's going to look like that. So these moles cancel. So that's how you use molar mass. The same setup could be true if I said, and so to finish that out, so you multiply 0.5 times 18, and you're just dividing by 1. There's 1s on bottom, so that's all you're dividing by, which something divided by 1 is itself. If I were to, instead of saying 0.5 moles, if I were to instead say that I have 36 grams of water, I'm still going to start with my given. So I'm going to put that 36 grams over 1 mole. And then I'm trying to figure out, or over 1, not 1 mole, 36 grams over 1. And I'm trying to figure out how many moles that is. I'm still going to use the molar mass because it's still water that we're talking about. But this time, since grams are on top, that means grams need to go on bottom. We're still using the same proportions. But it's the same work, it's the same method both ways. And so this time, grams can cancel out. And we can figure out if I had 36 grams of water, that would be roughly 2 moles. Because I'm going to take 36, multiply it across, which would just be 36 times 1. And I'm going to do the same underneath, times 18. So then I have 36 divided by 18. We're dividing by the bottom numbers. We multiply by those top numbers. So hopefully that makes some sense to you. So you can start to see the little things. Very important that we build up the little things to be able to work problems. So that's how we kind of use molar mass. In this section with limiting reactants, I didn't say it used too many other things for you, so we're going to just go with molar mass for now, and then we're going to talk about limiting reactants and percent yield and those kinds of things. So, I'm posting notes for y'all, and my notes have more of this information, but they will have all of the information I'm saying. Like, I'm not saying everything that's in the notes in these videos, but everything that's in these videos will be on the notes. So, look at the notes, and it's going to help you out. So there's some examples to work on stoichiometry if you'd like to try to do those so you don't get too stuck. But then if you keep going down in the notes, there's percent yield. And so percent yield is going to be comparing your actual versus your theoretical. Theories are hypotheticals. So it's what should happen. It's the mathematics behind it. So if I have some balanced equation and I say, hey, I should get this much out of it. I'm baking cookies and I say, I should get 24 cookies out of it. Well, in reality, maybe I do get 24 cookies. Maybe I don't. Maybe I get something less than that. Maybe I get 23 cookies, but that's my actual. So the 23 cookies would be my actual, what I actually got, what's physically in front of me, what was actually produced. Theoretical is what, when we calculate and we're saying, this should do this. So just like in your car when you're driving, you're like, oh, I'm getting 20 miles to the gallon. So I have 6 gallons left. I should be able to go 120 miles. That's your theoretical, the distance. That's what calculations say you should be able to go. And then whenever you are actually driving, maybe it's a really windy day, you hit a lot of traffic, and you actually drive 18 miles to the gallon. So you don't go 120 miles because that's not what actually happened. And so that's kind of to help you understand theoretical versus actual. I'm at 7 minutes. I'm going to stop this video. And in the next video, we're going to actually work percent yield problem, and then we'll work limiting reactant.